So let's take a look at an example. We have two vectors, u and v. We want to find the cross product, u cross v. Okay, so simple enough. So we want to find u cross v. So u is -4, 0, 1. We want to take the cross product of that with v, and the components of v are 2, -1, 2. So we're going to use our little mnemonic device to remember how to take a cross product. So we want the determinant of the matrix where the first row are the standard unit vectors I, j, k. The components of the second row of the matrix are the same as the components of my vector. So -4, 0, 1. And the components of the last row are the components of my second vector that I'm taking the cross product of. And I just want to say here that order here is important. The first matrix in the cross product has to be this row. The second matrix in the cross product has to be the last row. If you swap them, you will get a different answer, and we'll see that in a little bit. Okay? Okay, so we know how to take 3 by 3 determinant. So imagine canceling the row and column. So I'm expanding along the first row, so I'm circling I. Cancel out the row and column that I is in, and I'm going to multiply by the determinant of what's left. So I get I times the determinant of 0, 1, -1, 2. Next, j. So I'm going to get j times the determinant of -4, 1, 2, 2. So j times the determinant of -4, 1, 2, 2. Finally, k. And if we cancel out the row and column, we are left with -4, 0, 2, -1. So k times the determinant -4, 0, 2, -1. Alternate signs, so plus, minus, plus. Okay, great. So we're most of the way there. Now we just have to take some 2 by 2 determinants. I'll move a little bit faster with these 2 by 2s. So I get 0 minus -1, so that will be +1, minus j. And now let's take this 2 by 2, so I get -8 minus 2, that's -10. Plus k, and now take this 2 by 2. So multiply these two. -4 times -1 is +4, minus, and then the product of these two, 0 times 2 is 0, so that's 4 minus 0 is just 4. Okay. Now it looks a little funny because we've put the scalars after the vector, so I'm just going to rearrange it so that the scalar is in front of the vector as usual. So I get 1 times I minus j times -10, that becomes plus 10j because of the double negative, it's positive now. And then plus k times 4, that's plus 4k. And if I want to write it in component form, I have a 1 in front of that I, an invisible 1, and then 10j, and then 4k. So the cross product of vectors u and v is 1, 10, 4.